Sometimes what seemed brilliant in the logging industry years ago proved downright deadly in practice. Today we're going to uncover 10 perilous logging features that once dominated the forests only to vanish over time. It's a revealing look at how safety regulations and hard lessons shape modern forestry practices. Let's explore each dangerous innovation and discover why they eventually disappeared from the woods. Back in the early days of mechanized logging, tractors and skidders roamed the forest with a glaring safety oversight. They lacked any form of operator protection. These open-cab logging tractors from the 1940s through the 1960s placed operators in the most vulnerable position imaginable, completely exposed to the hazards of the forest. Companies like Caterpillar and International Harvester produced logging variants of their agricultural tractors with minimal modifications, often just reinforced undercarriages and winches bolted onto the back. Without rollover protection structures, ROPS, or falling object protective structures, FOPS, operators faced mortal danger every day. When a tractor tipped on uneven ground, common in logging operations, there was nothing to prevent the massive machine from crushing the driver. Equally dangerous was the risk from above. Falling branches, often called deadfalls by loggers, could strike operators without warning. Historical accounts from logging camps in the 1950s describe numerous incidents where operators suffered severe head injuries or death when dead branches were dislodged by nearby felling operations. By the late 1960s, equipment manufacturers began offering optional protective cages, responding to alarming accident statistics. The Timber Harvesting and Transportation Safety Foundation documented a 65% reduction in operator fatalities when protective structures became standard. Today's modern logging equipment features fully enclosed, climate-controlled cabs with reinforced protective structures, a far cry from those dangerous open designs. Long before lightweight composite materials and electronic safety features, early chainsaws were monstrous contraptions that often proved just as dangerous to operators as to the trees they were designed to fell. The notorious Widowmaker chainsaws of the early 1900s through the 1950s were massive, unwieldy machines that demanded brute strength and earned their ominous nickname. Early models like the two-man Distant Mercury from the 1940s or the hefty Maul tool saws weighed upwards of 60 pounds and required two operators, one to manage the engine end and another to guide the cutting bar. These behemoths vibrated violently, causing chronic hand and arm injuries among career loggers. What made these early saws particularly treacherous was their complete lack of safety features. Modern chainsaws incorporate chain brakes that stop the blade instantly when kickback occurs, that violent upward motion when the chain catches unexpectedly. Early Widowmakers had no such protection. When kickback happened, which was frequently due to the crude chain designs, the massive saw could swing wildly, causing horrific injuries. The fuel systems posed additional hazards. Without anti-flooding mechanisms or reliable throttle controls, these early saws could suddenly accelerate or stall unpredictably. Refueling hot engines frequently led to flash fires, as described in numerous accident reports from logging operations throughout the Pacific Northwest. Oh, and real quick, please take a moment to hit that subscribe button. It really helps out my channel. By the 1960s, manufacturers began incorporating safety features like handguards and improved chain designs. The introduction of the chain brake in the early 1970s by companies like Husqvarna and Stihl revolutionized chainsaw safety, reducing chainsaw-related injuries by over 75%. The steam donkey engine, pioneered in the late 1800s through the 1930s, revolutionized log transportation while introducing terrifying hazards. These stationary steam-powered winches from Washington Iron Works and Willamette Iron and Steel used massive boilers to pull logs across difficult terrain. Their primary danger came from steel cables spanning hundreds of yards through dense forest. Under extreme tension, sometimes exceeding 10,000 pounds of force, these cables became lethal when they failed. Pacific Logging Congress Historical Society accident records show snap cables could whip through the air with enough force to instantly decapitate workers or slice through small trees. The steam boilers created additional hazards. Operating under high pressure and remote settings with minimal safety standards, boiler explosions occurred frequently. The Logging Engineering Journal documented at least 40 fatal explosions in Pacific Northwest operations between 1900 and 1925. Communication challenges magnified these risks. Before reliable radios, crews relied on whistle signals that could be misheard, leading to logs being moved while workers remained in danger zones. As diesel engines replaced steam in the 1940s and hydraulic systems eventually superseded cable operations, the industry gradually abandoned these dangerous systems. Early mechanical skidders introduced in the 1950s and 60s brought mobility to cable logging, but retained many deadly hazards. These machines, produced by companies like Clark, Timberjack, and John Deere, use powerful winches mounted on wheeled vehicles to drag logs from cutting sites to loading areas. These early skidders lacked cable guards or operator protection. High-tension steel cables, often exceeding half an inch in diameter, ran openly across the machine with minimal guiding systems. These cables, under tremendous strain while dragging multi-ton logs, created constant hazard zones around the equipment. When cable snagged on stumps or rocks, the built-up tension could suddenly release, causing violent whipback. According to OSHA's historical records, early cable skidder accidents frequently resulted in traumatic amputations or fatal injuries when operators or nearby workers were struck by recoiling cables. By the late 1970s, equipment manufacturers began introducing cable guards, enclosed winch designs, and operator protection. Modern cable skidders feature fully shielded fair leads, automatic tensioning systems, and remote control options that keep workers away from danger zones. Innovations that have dramatically reduced once common injuries in logging operations. Before sophisticated hydraulic log loaders became standard, logging operations used primitive jammers to stack logs onto trucks and rail cars. These modified cranes, common from the 1920s to 50s, had minimal stability features and crude controls. Their primary hazard was inherent instability. Early jammers lacked counterweights or outriggers, risking tip-overs when lifting heavy logs at extended reach. Western Forestry Conservation Association accident reports ranked jammer tip-overs among the most catastrophic mid-century logging accidents, often crushing multiple workers simultaneously. Control systems were equally primitive. Operators managed boom movement, winch tension, and swing functions through mechanical levers, offering little precision and no failsafes. With direct mechanical linkages between controls and mechanisms, a broken lever or slipped cable could cause catastrophic boom or load movement. The logs themselves posed constant danger. Without hydraulic grapples, timber was secured using cables and hooks that could slip, especially with irregularly shaped or wet logs. When logs broke free, they could roll or swing unpredictably, crushing anyone nearby. The industry began transitioning to purpose-built hydraulic loaders in the 1960s, with Drott and Prentice leading innovation. These machines featured stabilizing outriggers, enclosed cabs, and precision hydraulic controls that dramatically improved safety and efficiency. In the evolution of mechanized timber cutting, there was a brief but extraordinarily dangerous period when massive exposed circular saw blades were mounted on mobile equipment. These circular saw felling machines, primarily used from the late 1940s through the early 60s, represented an attempt to mechanize tree cutting before the chainsaw bar became the industry standard. Manufacturers like Drott, Rome, and KG produced machines with enormous circular blades, some exceeding 4 feet in diameter, mounted on tractor fronts or specialized carriers. These blades spun at high speeds, powered by the vehicle's engine through mechanical powertrains. The most obvious hazard was the exposed blade itself. Unlike modern equipment where cutting components are shielded or remotely operated, these early machines positioned the massive blade directly adjacent to the operator with minimal guarding. According to safety reports from the Forest Products Laboratory, operators frequently suffered severe lacerations or amputations when maneuvering these machines through dense underbrush. Blade failure presented another lethal risk. These large diameter saw blades, when striking hidden obstacles like rocks or metal objects embedded in trees, could shatter catastrophically. Accident investigations recorded cases where blade fragments penetrated operator stations or struck workers up to 50 yards away. By the mid-1960s, the industry began shifting towards safer cutting mechanisms. Chain-type cutting heads, which eventually evolved into modern harvester heads, offered more control and could be better protected. Today's computerized harvesters feature fully enclosed cutting attachments operated from protected cabs, with numerous sensors and automatic shutdown systems to prevent accidents. A critical safety oversight in early logging machinery was the absence of deadman switches, emergency shutdown mechanisms that stop equipment when operators become incapacitated. From the 1930s through the early 70s, most logging equipment continued running even if operators fell unconscious, suffered heart attacks, or were thrown from controls. Early tractors, skidders, and loaders from Caterpillar, International Harvester, and Clark featured simple mechanical controls that remained in their set positions. If an operator collapsed with the machine in gear, equipment would continue moving until hitting an obstacle or running out of fuel. Cable yarders and loaders posed even greater hazards without deadman features. If operators lost consciousness while controlling suspended loads, the loads could remain suspended or drop when hydraulic pressure eventually failed. The industry began addressing this issue in the early 1970s after pressure from new safety agencies and insurers. Manufacturers incorporated seat switches, pressure-sensitive handles, and automatic idle-down systems that stopped dangerous functions when operators left controls. Modern logging equipment features sophisticated deadman systems, monitoring operator presence through multiple sensors, automatically neutralizing controls and engaging brakes if operators become unresponsive, a crucial advancement significantly reducing logging fatalities. From the 1950s through the early 1970s, swing boom log loaders became increasingly common in logging operations, but early models lacked critical safety features to prevent uncontrolled boom movement. These machines, manufactured by companies like American, P&H, and Northwest, featured rotating superstructures mounted on crawler tracks or rubber tires, with booms that could swing 360 degrees. The fundamental danger in these early designs was the absence of swing brake locks or hydraulic safety valves. When a machine was shut down or experienced hydraulic pressure loss, there was nothing to prevent the massive boom and attached grapple from swinging freely, potentially crushing anyone in its path. The Northwest 41 loader, a popular model in the 1960s, utilized open hydraulic systems without counterbalance valves or mechanical locks. If a hydraulic line ruptured, a common occurrence in the harsh conditions of logging operations, the boom could swing suddenly with devastating force. By the mid-70s, equipment manufacturers began implementing hydraulic safety systems with pilot-operated check valves that would maintain boom position even during pressure loss. Today's log loaders feature multiple redundant safety systems, including automatic swing brakes, load-holding valves, computerized motion control, and operator presence sensing. Before electric motors and hydraulic drives became standard, sawmills used exposed belt and pulley systems to transfer power from central engines to cutting equipment. These belt-driven operations, 1800s to 1950s, created hazardous environments with moving parts constantly near workers. Early mills used massive leather or canvas belts, often exceeding 12 inches wide, running on overhead line shafts. Companies like Frick, Lane, and American Sawmill Machinery built equipment around these transmission systems. The primary danger came from unguarded belts that could catch clothing, gloves, or hair, pulling workers into machinery with fatal results. Bureau of Labor Statistics data showed caught-in accidents led sawmill fatalities in the early 20th century. Belt maintenance posed additional hazards, as workers often adjusted loosened belts while machinery ran. The Carpenters and Joiners Union reported maintenance caused roughly 25% of belt-related deaths before lockout procedures existed. By the 1950s and 60s, direct drive electric motors replaced centralized systems, eliminating many dangerous components. Modern sawmills use individual motors with safety guards, automated feeding systems, and computerized controls for monitoring from safe distances. Among the most dangerous early sawmill positions was the log turner. workers who manually reposition massive logs before each cut. Until the mid-20th century, this role relied on human strength and simple tools, placing workers directly in the path of multi-ton logs and machinery. Doggers and turners used cant hooks and peavies, long wooden handles with hinged metal hooks, to maneuver logs weighing thousands of pounds. Mills by E.C. Atkins, Lane, and Frick required these workers to stand on or beside the saw carriage, manipulating logs by hand. International Woodworkers of America archives confirm log turners suffered the highest fatality rate in sawmills. When logs shifted unexpectedly, workers could be crushed against machinery or thrown into cutting equipment. Weather amplified these dangers. Ice-covered logs in winter became difficult to control, while wet bark during rainy seasons created slippery conditions. The industry addressed this hazard in the 50s and 60s, with hydraulic log turners and pneumatic positioning systems. Salem Equipment and USNR pioneered automated log handling technology. Modern sawmills use computerized scanning systems that position logs for optimal yield, with robotic turners handling massive logs with precision. Eliminating manual log turning represents perhaps the greatest sawmill safety improvement of the past century.